there are two types of waves. Waves can be transverse or longitudinal. First of all, let's look at transverse waves. Now, we've all seen a transverse wave. For example, when we throw a stone into a pond. Okay, you throw the stone into the pond and splosh. What happens next is that a wave is produced. Okay, it moves in this direction, spreading out from the point where the stone hit the water. Right, etc. And we call this, as it moves, we call this the direction of propagation or direction of travel. Now, suppose that we have, for example, a ping pong ball which is floating on the water, and we're going to observe how the ping pong ball moves as that wave propagates in this direction. So if we watch the ping pong ball, we'll notice that it vibrates up and down in this direction. So in the case of a transverse wave, the direction of vibration is always at 90 degrees to the direction of propagation. So just make a note of that. In the case of a transverse wave, we can say the direction of vibration is at 90 degrees, let's say perpendicular to the direction of travel. Now, the other type of wave is the longitudinal wave, and sound is an example of a longitudinal wave. So in this case, we've got a speaker which is a vibrating source producing the sound, and the sound travels in this direction towards the ear. Okay, so this is the direction of travel. Now, if we were to examine any one of these air particles with a high-powered microscope, say for example this one here, well, we could choose any of them because their movement would all be exactly the same. Then we would observe it moving backwards and forwards, first this way, then back to the middle, then this way, then back again. So it would be moving in this direction, backwards and forwards, in the same direction as the direction of travel. So this is the direction of vibration. So summarizing, we can say in the case of a longitudinal wave, the direction of vibration is in the same direction, that's parallel to, as the direction of travel. So examples of transverse waves are, for example, surface water waves and also electromagnetic waves, just put EM waves, of which visible light is an example. Okay, these are all examples of transverse waves. And examples of longitudinal waves, well, sound is an example. And also in the case of seismic waves, that's to say the waves that are produced by earthquakes, well, there are two types of seismic waves, and these are called P waves, and the P waves are longitudinal, and the other type are the S waves, and these are transverse waves. Now, we'll be looking at S waves and P waves in a later unit when we look at seismology and seismic waves.